Okay, we're back. Divide the whole thing through by 2. Hn squared, take 57n, plus 7. And then select try, -7 and 1. Here, maybe divide the whole thing through by 2, so 14n squared. No, divide the whole thing through by 4. 7n squared would be 92, 46, so 46n. 48, 24, like that. Okay. Factorize it. And we need 46, so who to try? 24 and 1 doesn't work. 2 and 12 doesn't work. 3 and 8 doesn't work. 4 and 6 does work. There. All to one side, please. 7a squared plus 40a plus 25 equals 0. Factorize. Five and 5. There. All to one side. Wrong. Okay. Oh boy. Okay. Try this. We need to take and take, so 28 doesn't work. 1 and 28 don't work. 2 and 14 don't work. 4 and 7 I said 4 and 7. That works. So x is 4 sevenths, or 7 over 5. If a quadratic equation can be factored, and each factor contains only real numbers, then there cannot be wait a minute. If quadratic equation can be factored and each factor contains only real numbers, then there cannot be an imaginary solution. True? I think that's true. If a quadratic equation cannot be if a quadratic equation cannot be factored, then it will have at least one imaginary solution. True. If I see these and they're both like false, I'm going to be so disappointed. Okay, wait. Any imaginary solutions? No, they're all real. Okay. Okay, left one true, right one cannot be factored. Oh, yeah. Oh, yeah, of course. Okay. Need to understand why this is the case. Okay. B squared minus 4ac, the discriminant. If this is not wait, am I even understanding this correct? You can't factorize the quadratic that I'm giving you, and therefore it has at least one imaginary solution. Yeah, but that's false for different reasons. No, wait. I understand what they're saying now. Just took me a while to process it, that's all. Because, like, and what do they mean by factored? Factored with integers? Because I can just always imagine or conjure up like a quadratic that has like horrible non-whole number roots, and that doesn't need any imaginary solutions. Okay. So that one's done. Next. Solving these equations by taking square roots. Let's do it. Take 6 from both sides. K squared equals 0, so K is just simply 0. Nothing sophisticated there. Divide both sides by 25, so V squared equals 1 over 25. Take the square root of both sides, so V equals square root of 1 over 25, which is the square root of 1 over the square root of 25, which is 1 over 5, plus or minus a fifth. N squared equals 36, so N equals plus or minus 6. Add 2, so X equals plus or minus the square root of 19. Add 3, so negative 1, 4. Negative 149. that is it really this? Root 149 over 3 plus or minus that times I? It is. How weird that they would do that. Add 5 to both sides, you'll get 612. 612 divided by 9. Okay, divide by 3, you get 204. And divide that by 3. You get 68. So r squared equals 68. So negative 320. So positive 64. So there. Negative 67. So A equals plus or minus root 67i. 324. Divide that by 4. Get 81. B is plus or minus 9. Negative 23 upon adding 8. Negative 23 divided by negative 8 is 23 over 8. So P is square root of 23 over 8 plus or minus, of course. Which is, well, what's square root of 8? Well, that's 2 root 2. Cool. 5x squared equals 5. X squared equals 1. So x equals plus or minus 1. 2x squared equals 8. So x squared equals 4. So x equals plus or minus 2. Adding 17, we get 2488. And then dividing that by 8, we get 311. So r is plus or minus root 311. Now, is 311 a prime? 3 does not go into it, nor does 5, nor does 7, nor 11, nor 13, nor 17, nor 19. And that's as far as you need to go. So it's that. 13p squared, take 3 equals 4,209. So you add 3 to both sides. So 13p squared equals 4212. 4212 divided by 13. Little bus stop. 13 goes into 42 3 times, with 3 left over. And it goes into 31 twice, with 5 left over. And it goes into 52 4 times. So p squared equals 324. And that's the square of 18. So p equals plus or minus 18. Next. 7p squared at 16 equals 2151. Take 16 from both sides, please. Okay, so on the right, I have 2141 and then 2135. 2135 divided by 7 Well, I noticed 21 and 35, and those are divisible by 7. So I'm going to have 305. So p squared equals 305. Okay. So p is plus or minus the square root of 305. So out of curiosity, what's 305? Would that be 5 times 61? So yeah, can't go any further with that. Now, negative 8n squared. If I add 13 onto this, I get minus 1126. 1126. You want to divide that by 8. Okay. 1 there, 3 there, 4 there. 8 into... It's just this. Okay. Well, that'd be nothing. And then we have 6 left over. And 60 divided by 8. Well, that's like 7. And then there's 5 left over. So 140.75. Really? Well, if it says so, n plus or minus root of this bizarre thing. I didn't think so. No. How is that possible? Did I just completely mess that up? Goes in once, 3 left over. Goes in 4 times. I must have not. Oh no, I'm supposed to take away 13. I see it. Fixing errors. That's what life is all about. So 1, 1, 5, 2. And we do that, and we get 1, 4, 4, 1 for 4. And that is indeed 12. 1 square rooted. Okay. Bingo. Okay, that was all handled. So we're just going to end this stream now and come back in a second.